Hi. Today's video involves curve sketching. Given all the information we can get about a function, first derivative test, second derivative test, asymptotes, etc., from that we can get a sketch of a curve. This was very prominent before graphing calculators. It still has some uses, but again, not as prominent as it used to be. For us, I'm just going to give us information, and rather than taking a function and do all the details of it, I have my first example already written up. This particular function has a vertical asymptote at x equals -1 and x equals 3. And if I don't give any more specifics than that, we will assume that my function is approaching infinity from both sides. Remember, that doesn't necessarily have to happen. So I've got a vertical asymptote at x equals -1 and at x equals 3. I have a horizontal asymptote at y equals 2, and because this does not occur from both sides, I'm going to tell you which side it is. The limit as x approaches infinity, positive infinity, is 2, so that is my horizontal asymptote on that side, whereas the limit as x approaches negative infinity is -2, and so that's my horizontal asymptote on this side. Okay, I probably should have used different colors. I'll leave the asymptotes black and make my axis blue. Okay, and make my graph purple. So now the first derivative is positive as when in the interval from negative infinity to -1. That means my function is increasing, decreasing, increasing, increasing, decreasing. Second derivative positive means up, up, down, up. And what we can do is we can kind of pair these together. These just should line up. We're going from negative infinity. My graph is increasing and concave up with this asymptote. So it has to look something like this. When I get to +1, when I get to -1, which is my vertical asymptote, so we get this goes to infinity. On the other side of -1, from -1 to +1, I am now decreasing and up. I'm going to kind of write this both places because it's in the middle. From -1 to +1, I am decreasing but concave up, something like this. I don't know exactly how far down it goes. I don't really care. We're just a kind of rough sketch. And then from 1 to 3, I'm increasing and up with another vertical asymptote at 3. So it does something like this. This is at 1. From 3 to 6, I am increasing and, oops, this should be up. I'm increasing and down from 3 to 6, and so I've got an asymptote increasing and down. This changes at 7. I am still going to be decreasing. So from 3 to 6, let's suppose here's 6, I am increasing but down. From 6 to 7, I'm decreasing but down. So here's 7. And then from 7 to infinity, I'm decreasing and up. And so it does something like this. This would be the overall sketch of this graph. Okay, let me erase all of this mess. and put up some more information. This will take me a little bit. Let's suppose I've got a vertical asymptote at x equal 2 with the limit as x approaches 2 from the left being positive infinity. The limit as x approaches 2 from the right is not infinite. In fact, it is the same as the functional value at 2, and we'll say that is negative 3. I've got a horizontal asymptote at y equal 1. That is the limit as x approaches positive infinity of f of x is 1. However, the limit as x approaches negative infinity of f of x is negative infinity. This has a horizontal asymptote, but only on one side. My first derivative, we'll say it goes negative 4. It's from negative infinity to negative 4, it's increasing. From negative 4 to negative 2, it's decreasing. From negative 2 to 2, it is increasing. And from 2 to infinity, it's increasing. And then for my second derivative, I have a value of negative 2. And in this entire region, it is concave down, and so I will write it both places. And then from negative 2 to 2, it is up, so it was negative, negative, positive. And then from 2 to infinity, it's negative, so it's down. And let's see what kind of picture we get. Oops, it should have been negative 3. I can't read my writing. Sorry, this should have been, let me fix this, from negative 3. Should be up. So here, it's down, here it's up. But it's not written very well. Do it that way. So we have the following. Now let me make my axis in blue. I've got vertical asymptote at x equal 2, horizontal asymptote, and that's from the left-hand side. It goes to positive infinity. It's going to be up here. Horizontal asymptote, y equals 1, and again that's on the positive side, so over here it's going to approach that. I have my function is increasing. Well, it goes to negative infinity as x goes to negative infinity. My function is down here at negative infinity. Going to negative infinity. It's increasing until I get x equals negative 4. Let's suppose this is negative 4. Here's 2, negative 2. So it goes increasing and down, something like this, to negative 4. It's decreasing and still down until I get to negative 3. So decreasing and down until I get to negative 3. From negative 3 to negative 2, it's decreasing, but now up. So it's decreasing, but now up. So we have an inflection point right there. From negative 2 to 2, it's now increasing and up, and I have this asymptote. So my graph does something like this. It reaches its bottom there, relative min at negative 2. And on this side, it is increasing concave down with this asymptote, and so therefore it looks like this. I should use a different color, but oops. Looks like this, with the functional value at 2 being negative 3 It does not go down to infinity. Starts there and looks like this. This would be the graph of the function, or rough estimate of the graph of the function.